Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra class. Today we're going to continue with functions, and we're going to learn how to write functions today. Writing functions is very easy, and it's also very difficult. I don't want to lie to you, okay? It's very difficult in the sense that you have to think, okay? You have to think. This is a very big thinking section because you're going to have to create formulas, functions, okay, equations for certain real-life situations. So to help you out with that, please remember all of the skills that we've learned up to now, because you can combine them all to make this a little bit easier. Let's just go over some pointers, please. Please remember, my friends, that a function is a relation where there is only one y value for any given x value. You cannot have two different y's for the same x. Please remember that the x values are known as the independent, the input, or the domain. Please remember that the y values are known as dependent, output, or range. Please remember that functions are set equations. They're set equations that do not alter. We talked about this yesterday. If I go and buy exactly one hamburger at ABC hamburger shops, and you buy the exact same hamburger, they better be the exact same price. Because it's working off of a function, off of a set equation, okay? For example, and you have to excuse me, I have a bit of a cold today, guys, sorry. Movie tickets cost $12 per person. So a function can be written for that situation since it is constant. What that means is, no matter what, however many tickets you buy, it's $12 every single ticket. Every ticket costs $12, so that's a constant change. So we're going to call y the total cost. I cannot tell you how important it is, my friends, to label variables. I mean, if you don't label things, this is going to be virtually impossible, for real. So y is the total cost since it is dependent. What is it dependent on? Well, it is dependent on the number of tickets you purchase. So we will call x independent. X is independent. That's going to be the number of tickets that you purchase, since you can buy as many tickets as you like. So when I'm writing the function y equals 12x, I just don't write it out. What I'm first going to do is I'm going to say y equals the total cost. So that way, not only do I know what I'm talking about, but the reader knows what I'm talking about. And x is the number of tickets. And now that I know that y is my total cost, x is the number of tickets, I can write my function y equals 12x. So if I buy one ticket, it's $12. If I buy 10 tickets, that's $120. I simply plug in the values and find my total cost. If I buy 2 tickets, well, 2 times 12, that's $24. If I buy 10 tickets, well, 10 times 12 is $120. X is independent. I can buy as many tickets as I want. Y is dependent. That cost depends on how many tickets I buy. Does that make sense? Okay, now, don't stress. We're going to walk through this one by one. Let's determine the function or the equation for each table or situation. Okay, this is the first time we've seen this. They're giving us a table of x and y values. Please remember that the x is independent and the y is dependent. Okay? Since the x is independent and the y depends on x, I have to do something to the x value in order to get the y value. So for now, we're just going to have to use our head. We're going to have to think about different possibilities. I can go ahead and teach you how to do this with procedures, but you're not there yet. You don't know what slope is, or rate of change, or the y-intercept. So I can't use those tools yet, so we're going to have to guess and check. And we're going to have to actually test things out. So you guys tell me, what is one possibility? What did I do to 1, the number 1, to get to -2? What could I have done to that? Sir? Okay, you went to the first one and the right one. Perfect. I'm going to first say what most people say, though, just so you can see how to test this. But great job. He guessed correctly, but a lot of people say, well, if I multiply -2 to x, okay, this is going to work. Well, let's see. When x is 1, what's -2 times 1? -2, so it works. Does it work for everything, though? Y equals -2 when x is 2. What's -2 times 2? -4. Is that what it should equal? So that does not work. So that's gone. Bye-bye. So now we're going to go to the first guess of the day. Actually, it wasn't a guess. It was a very good answer. My boy said, take the x value and subtract 3. Let's see if that works. Y equals x minus 3. Okay. When x is 1, what's 1 minus 3? -2. Works. Okay. When x is 2, what's 2 minus 3? -1. It works. When x is 3, what's 3 minus 3? 0. It works. When x is 4, what's 4 minus 3? 1. It works. So what is my function? My function that works for every single ordered pair that I have here is y equals x minus 3. So you're going to have to guess and actually check until you see that it works for all of them. How about for B, my friends? What could I have done to x to get to the value of 1 to get to 3? Yes, sir. Multiply by 3. Let's see if that works, my brother. So he's saying y equals 3 times x. Well, when x is 1, what's 1 times 3? When x is 2, what's 2 times 3? When x is 3, what's 3 times 3? When x is 4, what's 3 times 4? 12. So does that work? Yes, it works for all of them. We're good. Great job. Well done. So for tables, for right now, they're going to be pretty easy like that. And as we get further and further along in the year, they're going to get more difficult, as everything. But we got to walk before we run. So the question is always this. What did I do to my first x value to make it turn into my first y value? That's the question. Once you figure that out, does it work for every single x value? Does that make sense, guys? So what did I do to the 1 to get to the 3? And does it work for every single x value? We cool? All right, great. Thank you. Okay, how about some word problems? The gym you join costs $30 per month, plus a one-time fee of $250. Sir? Okay, the equation is great, but let's always do this step by step. Thank you, though, my brother. What is the y? Y is the total cost. See what I'm saying? You had the right equation, but you didn't really understand what you were doing there. Thank you. This is a great mistake. And your x would be? The number of months. Very good. Now that you know what your x and y are, it's very simple. Y, my total cost, just like you said, equals $30 per month plus a $250 one-time fee. Do you see how it's a lot easier once you actually locate what the x and y are? You can read the question again and literally just plug it in. Does that make sense, guys? Okay. ABC cell phones charge $20 per month for unlimited usage of the phone. Yes, sir, my brother. Define variables first. What's the Y? No, what's the Y? Total cost. And then what would the X be? Very good. Number of months. Excellent, son. Excellent. Very good. So what would my equation be? What would my function be? Y, which is the total cost, equals $20 per month, which is X. Fantastic. Excellent, sir. Does that make sense, guys? Label, label, label. Always label your variables, my friends. It's going to make your life a lot easier in the end, I promise. Questions? Okay. Now, in this page, guys, I think that in your PDF, I don't know why, A, B, C, and D, it was blank on you. I'm sorry about that, okay? I'm sorry about it. You can write that down either now if you're quick, or if not, you can rewatch the video and write the questions. For now, let's go over the skill, though. I want to determine in all of these the dependent variable and the independent variable. So for A, in the winter, more electricity is used when the temperature goes down and less is used when the temperature goes up. So what's the independent and what's the dependent here? Come again? The amount of electricity used is dependent. And what is it dependent on? Yes, temperature, which is independent. Guys, the weather outside doesn't depend on your bill, does it? Your bill depends on the weather, right? Does that make sense? Okay? The cost of shipping a package is based on its weight. What is the dependent? And what is the independent, my friends? Sir? The cost is dependent. Very good, my brother. And very good, son. The weight is independent. Absolutely. If you guys have ever shipped something or mailed something at the post office, you put it on a scale. The heavier it is, the more it costs. Very good, son. Very good. I'm glad you don't think it's hard. Good job, kid. Well done. Good attitude. The faster Mike walks, the quicker he gets home. This is a good one. The faster Mike walks, the quicker he gets home. This is a good one. What's dependent and what's independent here? This is a good one. Yes, sir. Huh? Dependent is actually not speed this time. Think about it. The faster Mike walks. So isn't it Mike's decision to walk either slowly or quickly? So his speed is independent. And then what's dependent here? The time he gets home. Right. Right? Because the faster I walk, the less time it takes me to get home, doesn't it? Usually time is independent, but in this case, the way I wrote it, time is dependent on how fast you are. Okay? A company charges $10 per hour to rent a jackhammer. A company charges $10 per hour to rent a jackhammer. What's my dependent? What's my independent? Sir. Independent is the number of hours. Very excellent. The dependent is the cost. Absolutely. If I rent it for 10 hours, it's $100. If I rent it for 2 hours, it's only $20. So my cost, Y, dependent, depends on my number of hours, X. Very good, very good. Apples cost 99 cents per pound. What is my dependent? And what is my independent? Ooh, nice. Dependent cost, for sure. independent. The number of pounds. Fantabulous, guys. Fantastic. Well done. So it makes sense, though. Promise? Okay. Again, I'm sorry that there was that mess up with the whole PDF translation. I don't know why it did that. I really apologize. Now, all right, where are we going with all this? We're going to talk about what a true function is, what a function rule is, and what function notation is. So please be careful, guys. Please pay attention. A function rule is an equation that represents an output value y in terms of an input value x. Guess what? We already did that. Okay? For example, that's a function. Y is in terms of x. X is independent, y is dependent. So that part is nothing new. A function rule is basically an equation in which it represents an output value in terms of the input value x. You can write a function rule in what's called function notation. Shown below are examples of function rules. Okay, let me explain this and let me be really clear. Because a lot of people freak out. Okay, a lot of people don't understand this. I'm going to do the best I can to make this really easy for you guys, okay? I swear I'm going to do my best. First of all, let's just look at this guy here. We've already been working with this. Y equals 3x plus 2. Y is the output or the dependent. X is the input or the independent, okay? That makes sense so far, right? All they're doing when you have a quote-unquote function rule in function notation, guys, they're simply replacing the y with an f of x. That's all. So in this next example, I have f of x equals 3x plus 2. I swear to you, it's the same thing as saying y equals 3x plus 2. The popular question is for tomorrow, if it's the same, why do they change it? Because when we get further and further on, you can have different labeled functions. Let me explain by the way I read this, okay? When I say f of x, you could read it several ways. You could read it as simply f of x, period, f of x. You could read it as function f of x. All they're saying is that this function name is f of x. Or, my favorite, the one that really, I think, drives it home, the one that really makes kids understand this is the way I write it this way. Function f with independent variable x. So when I have f of x, I know that this is a function called f, and my independent variable is x. What if I have g of c? I know that this is function g with independent variable c. What if I have h of k? I know that's function h with independent variable k. You with me so far, my friends? Okay, now, another powerful tool of function notation. The original equation I had was f of x equals 3x plus 2. Sometimes I'm going to say things like, evaluate f of 1. What did I replace the x with there, guys? A 1. That was replaced by a 1. So what do you think this x is going to be replaced by? You are simply going to evaluate. Remember how I said all of these terms are going to come back to haunt us or to help us? When you evaluate, you plug in a known value. So in this particular case, f of 1 equals 3 times x, which I replaced with 1, plus 2. So f of 1 equals 5. Now, I had someone in my last class say, oh, Do you solve for f? What? No, no. Is f even a variable? F is simply the name of the function, isn't it? Okay, so in that case, moral, that's super. What is this telling me, though? This is telling me the following, guys. Isn't this function f with independent variable x? What did I choose for my x value? What did I find my y value was when x is 1? 5. Do you see what I did there, guys? Do you see the connection here? Because this is huge. I know some of you are looking at me going, Mr. Moore, you're getting a little bit too happy about functions. I know, but I love this stuff. I want to make sure you guys really get this. Does that make sense to you? Promise? May I continue? Thank you. Now let's put it into play. For function f of x, remember this is function f with independent variable x equals negative 2x plus 5. What is the output for the inputs negative 3, 0, and 1/4? Basically, you could do this several ways. This is what I like to do. Okay, I know that my x's are going to be negative 3, 0, and 1/4, right? Guys, yeah? So I'm going to first find, remember, I'm working with f of x equals negative 2x plus 5. So I'm going to find f of negative 3. What is the only thing I'm doing here when I put a negative 3 in that x? What does that mean I replace the x with? Negative 3. So negative 2 times negative 3 plus 5, that's going to be 6 plus 5, which is 11. So when x is negative 3, y is 11. F of 0, well, f of 0, I replace my x value in function f with a 0. So I'm going to evaluate. 2 times 0 is 0, plus 5 equals 5. So when x was 0, my y is 5. F of 1/4, that's going to equal negative 2 times 1/4, because I evaluate for it, because that's what I replace x with, plus 5. Negative 2 times 1/4 is negative 1/2, plus 5 is 4 and 1/2. So when x is 1/4, my y was 4 and 1/2. Does that make sense, guys? Yes, no, maybe, kind of, sort of? Come on, talk to me, guys. Awesome. Thank you. Let's continue then. I have function f of x, that means function f with independent variable x, and that equals negative 4x plus 1. I want to find the outputs for the inputs negative 2, 0, and 5. So I have my x and my f of x or y. When x is negative 2, 0, and 5, I want to find my f of x value or my y value. So f of negative 2, when x is negative 2, and I plug it in, I got 8 plus 1, which equals 9. F of 0, I'm replacing x with 0, so negative 4 times 0 is 0 plus 1 is 1. F of 5, when x is 5, negative 4 times 5 plus 1 is negative 19. So again, am I solving for f here? No. I'm solving for y in all of these, right? Just remember, f of x is the same thing as y, except the function notation labels the name of the function and it tells you the name of the independent variable. That's it. That makes sense, guys. Promise? May I continue? Thank you. Tickets to a concert are available online for $35 each, plus a handling fee of $250. The total is a function of the number of tickets bought. What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. I'm going to show you both ways to do this. Without function notation and with function notation. Because either way, it's a function. So, without function notation. Without f of x. Okay, label, label, label. What's my y and what's my x? Y is the cost. Thank you. What's my x? The number of tickets. Very good. What's my function, guys? Y, which is my total cost, equals? Not 35x. Oh, yes, it is. Each. Yes, it is. 35x plus 250. Does everyone see what I did there? Now, if I want to write this with function notation, with f of x, nothing has changed except that I replace y with f of x. So this time your f of x is the cost, but my x is still the number of tickets. So my f of x, function f with independent variable x, equals $35 for every x ticket plus $2.50. This is identical to this, except I replace f of x with y. No big deal. Now, evaluate the function for 4 tickets. You can evaluate it for both of them. Y equals 35 times 4 plus 250. So that's going to be 140 plus 250 is 142.50. That's my cost. Or f of 4 equals 35 times 4 plus 250. Why did I put f of 4? Because I replaced the x value with 4 tickets, which is what I'm looking for. So I have, again, 142.50. Does that make sense? You guys see how they're related? Do you understand the difference here, guys? Promise? Okay? You're buying bottles of water for a sports drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of the purchase? Evaluate the function for 15 bottles. What do we got here? Yes. What's my f of x or my y? Either one. What's my f of x? Oh my lord. Come on now. What's my f of x or y? Very good, son. The cost. Excellent. What's my x, my independent variable? The number of bottles you purchase. Very excellent. Very excellent. So what's my formula, or function rather? Y? 119x. If I wanted to write it in function notation, f of x equals 119x. And how do I find the value of purchasing 15 bottles? How do I evaluate the function for 15 bottles? You replace x with 15 and plug it in. Very good. So that's going to equal 119 times 15. Then we're going to go back to the old school. That's 95911. Excuse me. I have a bit of a cold. And that's 12. So it's going to be, the price of 15 tickets will be $17.85. Does that make sense, everybody? We're good with that? Thank you very much. Excellent job today. Hope you learned a lot.